kinetics. This is known as Arrhenius equation. It gives the empirical relationship between the rate constant of the reaction and the temperature. The empirical relationship between rate constant of the reaction and temperature. In most of the cases, reaction rate or reaction speed increases upon increasing temperature. But there are few cases in which those are known as exothermic reactions, which upon increasing temperature the rate decreases. So for this equation is exceptional, not applicable for those reactions. This reaction is applicable for only for reaction which whose rate increases upon increasing temperature. The rate constant meaning it is the rate of the reaction when the concentration is 1 molar. 1 molar means the reactant amount is 1 mole. It is present in 1 liter of its space in which the reaction is taking place. This is the reacting space. So it contains 1 mole. As you know, the reaction does not take place in one lot. It occurs fraction by fraction. What fraction of molecules will react every time? That is fraction by fraction. That the Arrhenius equation tells. There are two mathematical factors. One is A. It is pre-exponential factor. It is also called as Arrhenius factor or frequency factor. That is the exponential factor. It is containing energy of activation and temperature, and or gas constant for 1 mole, universal gas constant. These two factors have their own contributions. What is that factor? Arrhenius factor stands for. It stands for fraction of the molecules which have properly oriented at the time of collision. Let us go for in detail afterwards. This factor stands for fraction of the molecules. That is fraction out of 1 mole. Fraction of the molecules which possess energy of activation. That is energy for activation for the reaction. And the criteria for this is that for any criteria, reaction criteria, according to collision, there must be a collision between the molecules. If there is no collision, no reaction takes place, because the collision will bring the molecules closest possible distance that is needed, and the molecule should have proper orientation, and molecule should have energy of activation. What is meant by proper orientation? That is a proper orientation of molecules at the time of collision. It is called as an effective collision. It is improper orientation. What is proper orientation? At the time of collision, at the time of the molecules approaching each other, the site of reaction, this point is the site of reaction of this molecule, this point is the site of reaction of this molecule, these are reacting molecules, for example. They should face each other, that is that at the time of collision. The reason that, so here the site of reaction, they are far from each other when they collide like this. It is an ineffective collision, reaction is not possible. That is improper orientation. What is the reason for this reaction to take place? Example, I am taking this. That is decomposition of hydrogen to hydrogen and iodine. That is the molecules, two molecules of HI, the bond between them. The molecule should have this kind of collision. If they collide like this, this is the way of collision. The collision between this take place like this, that is a proper orientation. If they are oriented like this at the collision, then the reaction is possible. Why? During the reaction, chemical bond, that is, some chemical bond breaks. When they begin to break, new chemical bond forms. For the arise of new chemical bond, the atoms should stay very close to each other. That is why, by forming the bond, if they are very far from each other, no no chances of forming chemical bond. Only for the formation arise of chemical bond, the atoms should stay very close to each other. So that is what is that? There is a kind of orientation we need. When the chemical bond begins to break, new chemical bond arises. Only when they lie close to each other, close to the atoms which are in which new chemical bond is forming and new chemical bond is forming at the time of collision. That is why while breaking, new chemical bond arise, break, and completely break, a new chemical bond, solid line is forming, complete chemical bond. So these two separate into hydrogen and I2. So this is what a transition state. Transition means it is a change taking place, reactant into product, and intermediate, that is the most important, is called as activated complex. For this kind of reaction, the molecule should have what is called proper orientation. That is not proper orientation. Here the side collision is there, but this collision will not produce a reaction. So that is what this Arrhenius expression, Arrhenius factor, that is tells us, implies a fraction of molecules which are properly oriented. There are many collisions, not all collisions, only a fraction of collisions which are oriented like this. And at the same time, those fraction of molecules have the energy, what is that? Energy of oxidation. Not only oriented, they should have energy of oxidation. Then only reaction is possible. That is the criteria for reaction. In accordance with the collision theory and Arrhenius theory, collision is a must. And there must be a proper orientation of molecules. And the colliding molecules should have energy of oxidation. Then only the reaction is fruitful. The collision is fruitful. So now let us understand the meaning of energy of oxidation. For this we need this diagram, energy profile diagram. Here, a reactant molecule is changing into product molecule in the reactant system. That is what here reactant molecules are here, product molecules are here. Here energy axis and the reaction coordinate axis. That is, during the reaction, the energies keep changing in the molecule. From changing it, what is that? Reactant into product, energy changes like this and like this. While changing from molecule reactant into product, that is the variation of energy in the system, the reactant system. What is this energy? This energy is not zero is here. This energy is energy the reactant molecules have. Normally, the reactant molecules possess amount of energy. That is the energy of the reactant molecules. What is the energy? This is threshold energy. Threshold energy. So, this energy is not sufficient for a chemical reaction. This energy is not sufficient to break a chemical bond. This molecule should have this energy for a reaction to break a chemical bond. So only when the reactant molecules gain the energy in excess like this, then the energy they have. So the reactant molecules gain this energy, Then the possibility of breaking chemical bond, new chemical bond formation. After the chemical bond formation, there product molecules, what is that? Decreases its energy, attains the energy. That is a state lower than, energy status is lower than this. This is the feasibility of the reaction. That is, for this is a thermodynamic possibility, feasibility of reaction. Then what is this threshold energy and normal energy? Energy of activation. Reactant molecules, what is that? Usually what is that, the reacting system? How they gain the energy like this? In excess, because by collision. In the reacting system, all the molecules are keep colliding. So in every fraction of second, what is that? All the molecules are colliding. During the collision, some molecules gain energy, some molecules lose energy, and some fraction of molecules keep gaining energy, and gaining energy, some losing energy. Finally, a fraction of molecules gain this amount of energy in excess. Then they can react, forming product. That is the earliest says that energy of activation means it is the energy in excess. What the energy they have should gain to undergo chemical change. That is called energy of activation. Or is a difference between this energy is called as threshold energy and reactant energy. The difference is called energy of activation. For reactant molecules need to cross this barrier, energy barrier, for a change of reactant into product. That is what. Here, that is at the top of the energy barrier, activated complex. So that is the concept. What is that? Hermes says energy of activation means normally the reactant molecules have the energy. That is, that energy is not sufficient for a reaction to take place. They should acquire, what is that, in excess what they have, that excess energy is called as energy of activation. They acquire by repeated collision, fraction by fraction. That is why a fraction of the molecules which have energy of activation. So this fraction into this fraction gives one more fraction. That fraction is actually less than either this fraction or this fraction. That fraction will undergo chemical reaction, fraction by fraction. That is the Hermes equation, concept of Hermes equation. So here frequency factor, Hermes factor says only, it says what fraction of molecules which are properly oriented at the time of collision, and what fraction of molecules which possess energy at the time of collision. Then collision is a must. Without collision, no reaction. So that is what, these are the three things which needs to explain why the reaction takes place in the system. So this is about the Hermes equation, that is the meaning hidden in the empirical relationship between the rate constant and the energy of activation, temperature and Hermes factor, exponential factor. Let us write this expression. We can write this expression in the graphical form. That is a mathematical form and graphical form. Since there is an exponential term, so we can eliminate the exponential term by taking logarithm on both sides. Taking log on both sides, the same equation equals logarithm of this plus logarithm of this, sum. Log of this plus log of this. And exponent into log E is equal to 1. Reduce to this. And this is a natural log. What is natural log? It is log E to the base E. That is logarithm to the base 10 is 2.303. So convert this logarithm to the base 10. Log to the base 10. It is 2.303. That is why dividing throughout by 2.303 we get this equation. So 1 by t separate we have taken. So these are the variables. Temperature and rate constant are the variables. These are the constants. These are the constants for a particular reaction. This is a universal constant for all the reactions. So when you draw the graph, just a graphical notation is between this log k and 1 by t. So equation of straight line, this is the intercept. There is straight line like this, downward, minus. So that 1 by t means with what is a decrease in temperature. Here 1 by t means increases. With decrease in temperature, rate constant decreases. Vice versa. In this direction, with increase in temperature, rate constant increases. Either way. That is 1 by t. This shows that. So the 1 by t increases means temperature decreases. So rate constant and temperature are directly related. So upon increase in temperature, rate constant increases or rate of reaction increases. This intercept gives a what is the value of, we can calculate the value of A for a reaction. If you have a graph from the experimental data, we can have this graph. And from the slope, so slope is this, A by RT. Value of what is known. We can evaluate the value of the energy of activation for the reaction. So from the experimental data, if we have this graph, we can simultaneously exploit what is, we can simultaneously evaluate the value of A and value of B. That is one way of evaluation. And another way of calculation of energy of activation, that is mathematical calculation. I am taking any two values. That is value what is when temperature is T1, K is K1. That is at different temperature we have different values. When temperature is T2, the K is K2. The same Hermes equation here and simultaneous equation, divide one by the other. Simplify. Take it in numerator. Minus becomes plus. That is T1. Minus becomes plus. And take what is the common factor, E by R, the exponential factor. And this becomes, taking LCM and simplify. This is exponential term. Just eliminate exponential term, taking log on both sides. Log of this, log of this. And log E, that is this into log E is 1. That is what it is. Log K. And finally EA is equal to cross multiply. You get this. So this is the final expression. If you know from the experimental data, rate constant of any reaction at any two different temperatures, T1 and T2, at known two temperatures, if these rate constant are determined, we can evaluate the energy of activation of the reaction. Another way of mathematical calculation. That is one we have calculated, we have taken this. As you know, in most of the cases, rate of the reaction doubles for every 10 degree rise in temperature. The experimental is proved in 99, that is 90% of the reaction. But very few reactions, rate of the reaction triples for a rise of 10 degree rise in for a rise of 10 degree temperature. So most of the case, the rate doubles. That is, rate constant doubles or rate doubles for every rise of 10 degree temperature. So let me take these values. T1 is the temperature 298 Kelvin. Remember, this T1 and T2 temperature values should be written in Kelvin, not in degree centigrade. If they are given in degree centigrade, convert into Kelvin. 273 plus degree centigrade. That is 298 Kelvin. 27 degree centigrade. 308 Kelvin at this temperature. So this is a rise of temperature 10 degree. If K1 equals K, K2 equals to K double. For this rise in 10 degree temperature, rate constant double. That is generalization I done. So substitute into the equation and simplify. Temperature is this difference 10 degree. Temperature is T1, T2. Logarithm of 2K by K. K cancelled log 2. Simplify, multiply and divide by 2. Find the log 2. We get this value, that is 52,897.8 joules per mole. The unit is joules per mole. Energy of operation per mole. How many joules we require? Excess energy in addition to the energy they have. That is why joules per mole. In Kelvin, kilojoules. In kilojoules, 52. 10 to the power of 52.89 kilojoules per mole. Energy of operation. This is how we can calculate. If you have other values, directly substitute and calculate. Let us work out in other problems. That is the importance or significance of the Arrhenius equation. Is most important in energy of oxidation. What is energy of oxidation? Reactant molecules have the energy. That energy is not at all sufficient for the reaction. They should gain in excess what they have. At least this amount of energy. That is the energy of oxidation. They can gain by repeated collision. Losing and gaining. Again, finally a fraction of molecules gain the energy. That is the energy of oxidation. Very important concept. Without which reaction is impossible. And one more factor which contribute for what is that a fruitful reaction is this: proper orientation and collision. Yes. Thank you very much.